In this video, I will explain the definition of a derivative from the first principle, or simply what it means in relation to slopes and limits. But before we do that, I would like to review two terms that I am going to be using in this video and that you may or may not know, which are secant and tangent. These concepts are often illustrated with a circle. So a secant is a straight line that cuts the curve at two or more points. Here you can see the 2 points, and it continues on beyond the 2 points. It continues on beyond the circle. And the tangent is a straight line that touches the curve or the surface at just one single point without intersecting it. This is a secant, this is a tangent. Now that we have remembered this, I will start with a random function. Let's just use the graph of the function. In this function, we are going to have 2 points, which are going to be point A over here and point B over here. Let's call the space between these 2 points H. The value of the initial point in this axis down here will be x, and the value of B will be x plus h, since we're adding the distance of h to the value of x. And here we will have our values of y corresponding to each of the points. We will refer to this first value as f of x, since it corresponds to that point in the x-axis, and our second point over here would be f of x plus h, since it corresponds to this one down here. Now let's write the coordinates over here. Point A is going to have coordinates x and f of x, and point B is going to have the coordinates x plus h and f of x plus h. If we do the slope formula for this, let's remember that the slope formula is written as m, and is the change over y over the change in x, or alternatively y2 minus y1 over x2 minus x1. Using these coordinates over here, we would have m equals y2, which is f of x plus h, minus y1, f of x, y1 f of x, over x2, which is x plus h, minus x1, which is just x. If we simplify this formula, x and x cancel here, we would have f of x plus h minus f of x over h. This is the slope of this space between A and B. This would be what this represents graphically, would be a line that connects these 2 points and goes beyond. This, as you can see, is secant. It touches the 2 points, it goes beyond them. However, what could we do if we were required to find the slope of a tangent? A tangent that only touches one random point in the space H. Well then, in that case, we would need to reduce the space H that exists between point A and point B. We are going to make B get closer to A. Closer and closer and closer. B, B, B. So H starts shrinking. It is decreasing. H is now here, H is here, H is here, and we keep shrinking it until it reduces to a single point, the single point that the tangent would touch in the function. As H is shrinking, we can notice that the value of H is gradually becoming 0. It is becoming smaller. H, thus, is tending to 0. Its value reducing without hitch as we get closer and closer to the single point the tangent touches. This means that to find the slope of the tangent of the line that touches one single point using this simplified formula over here, we would need to specify that H is tending to 0, and this can be done through limits. What would be the way we write the slope formula to indicate that H is tending to 0? Well, the expansion of this would look like x2 plus 2 xh plus h squared plus 1 minus x squared minus 1 over h. 1 minus 1, x squared minus x squared are simplified, and this leaves us with 2xh plus h squared over h. Now we use the common factor here, and the common factor is the h. As you can see, h times 2x plus h again over the h. H cancels out, and we are left with 2 plus h. Since we know that we are using limits and that h is tending to 0, h's value becomes 0, and we are left with 2x only. So f prime x would be 2x.